Coming on to the next question. In this we have to use the age and productivity data from the previous data set which we were given, and again we have to calculate the z-score normalization, compute Pearson correlation coefficient and covariance. So for z-score normalization we already know the formula, and we will just put the values over here for both age data and for productivity data separately. Then coming on to the next part, which is calculating Pearson correlation, which will be 0.82, and covariance, which will be 94.46. The formula for Pearson correlation coefficient is basically covariance between x and y divided by the variance of x into the variance of y whole square root. And for covariance we can use the same formula, but for calculating it separately we can use expectation of xy minus expectation of x into expectation of y. Then coming on to the next question, which is question number 17. So in this question we are given a data set of student project evaluation scores. We have to partition it into bins using three different methods. So given scores are already over here, which is in sorted form, and first we will do it by equal frequency partitioning. We will divide the data into so that each bin has equal number of values. Total values are 12 and number of bins equal to 3, so values per bin will be 4, that is each bin will have 4 values. So that's how we divided it using the first method, which is equal frequency partitioning. Then we will go on for the next method, which is equal width partitioning. In this we calculate the minimum, maximum values, and then we calculate the range, which is nothing but max minus min. Then number of bins as given in the question is 3. We calculate the bin width by dividing range by the number of bin, which is equal to 70. So it will give us a range. So 5 plus 70 is 75. So 5 the range is 5 to 75. All the data points in this region will lie under this bin, and 75 plus 70 will be 145. All the data points lying in this range will be in this bin, and similarly for bin 3 as well. Clustering, we can use various methods, but here we have used similarity, that is low, medium, high scores. Cluster 1 that is the low scores, cluster 3 that is the high score, and cluster 2 is the medium score. It is already understandable. Then moving on to the next question, which is summarizing these attribute selection techniques. Attribute is nothing, just the features that we use to train different ML models. So for this we have created a flowchart. So this is our flowchart for attribute selection techniques, which is nothing but feature selection techniques. So first of all we start with analysis, which is the first step for all the three. In forward selection, what we do is we start with no attributes. In backward, with all attributes. In hybrid, we take a subset of all attributes. Suppose there are 200 features, we only use 20 of them for a subset. Then we add attributes with highest performance, like the ML model has accuracy highest in this, so we will add that particular column, that is that particular feature, and in backward elimination we remove that least useful feature from the column based on the metrics like accuracy, precision, etc. In this we do in hybrid method, we do alternate, that is adding and removing at the same time or as per the requirements. Then we evaluate the performance in both, and in all three we evaluate and re-evaluate after each step to avoid any local optima. In each step it's the same. This step number 3 is same for all. We in the forward selection we continue until no further improvement. In backward elimination we continue until no further improvement. Okay, it's basically same for both. And but in hybrid we stop adding and removing when no improvement. So it's also same for all the three methods. The main difference was just over here, which is adding, removing, or alternatively using both as per the requirement, and we end the process for feature selection. Thank you for watching the video. Stay tuned for another playlist on part D of our first internal of introduction to data science, which will be about compatibility and pairing collaboration analytics.